According to the National Electrical Code, specifically Section 445.13, conductors must be rated at 115% of the generator's nameplate rating unless an exception is met. Let's consider a 60 kV generator operating at single-phase 240 volts. To determine the required conductor size, firstly, calculate the amperage. The amperage is calculated by dividing the kilovolt amps by the voltage. In this case, 60 kilovolt amps converted to volt amps is 60,000 volt amps. This is then divided by 240 volts, resulting in 250 amps. Secondly, take 115% of this amperage. 115% of 250 amps is 287.5 amps. Therefore, a conductor capable of carrying at least 287.5 amps is needed. This calculation leads to the question of what happens if the generator has an internal 200 amp breaker. The answer is that you still need to size the conductor for 287.5 amps. The reason lies in the purpose of the internal breaker. The internal breaker is primarily designed to protect the generator itself from overload conditions. It is not intended to protect the conductors from overheating due to excessive current draw. The National Electrical Code mandates that conductors be sized to handle the maximum current the circuit is capable of drawing. This requirement is crucial for preventing conductor overheating, which can lead to insulation damage and potentially cause a fire. In this scenario, even though the generator has a 200 amp breaker, it is still capable of drawing 287.5 amps according to its nameplate rating. The conductor must be sized accordingly to handle this potential current. The 200 amp breaker will only trip and protect the generator if the current exceeds 200 amps, but it does not guarantee the conductors will be protected from overheating if the current is between 200 and 287.5 amps. Therefore, the conductor size must be determined based on the 115% calculation, ensuring it can safely carry the maximum potential current. To reiterate, the conductor needs to be rated for at least 287.5 amps. Consulting the NEC tables, specifically Table 310.16, will help determine the appropriate conductor size based on its ampacity. According to Table 310.16, a 350 kcmil copper conductor with a 75 degrees Celsius insulation rating is rated for 310 amps in an ambient temperature of 30 degrees Celsius. This conductor would meet the requirement of being rated for at least 287.5 amps. Remember that various factors can affect the ampacity of a conductor, including the ambient temperature, the number of conductors in a raceway, and the type of insulation. Correction factors and adjustment factors may need to be applied as outlined in the NEC. Always consult the latest edition of the NEC and follow all applicable codes and regulations. Proper conductor sizing is essential for ensuring the safe and reliable operation of the electrical system. Neglecting this step can lead to hazardous conditions. In summary, even with a 200 amp internal breaker, the conductors must be sized to handle the 115% of the generator's nameplate rating, which in this case is 287.5 amps. This ensures the conductors are adequately protected from overheating and potential fire hazards. A 200 amp breaker protects the generator itself from overloads exceeding that value. The principle behind this requirement is to protect the entire electrical system, not just the generator. Conductors are a critical component of the system and must be sized appropriately to handle the potential current flow.